Good morning, dear students. We shall be continuing with the solid state. If you can remember, in the last session, we discussed about solids such as crystals and amorphous solids. We have also learnt about two properties, isotropy and anisotropy, where isotropy was what? Having similar property all throughout. Iso means similarity. Anisotropy means what? Having dissimilar properties along the different directions. Now let us come to the more detailed version of a solid state. Here in this chapter we shall learn about lattice, how a structure is formed in a solid state, in a solid crystals to be more precise. So let us begin with the chapters today. To begin with the lattice, let us first understand what is it. It's nothing but it's an arrangement of molecules and atoms in a three-dimensional space to form what? A crystal. Now we have to understand this thing that whenever we arrange atoms or molecules in a very particular manner, what happened? Crystal structures is formed. I have given a small diagram for y'all to understand this thing. What you can notice over here is that there are different cubes that is joined head together. Now, when you're going to see this cube, there will be one cube that will be resembling the other cube. So what we can say is that this one single cube is responsible or is the monomer unit that makes up the whole crystal. Thus, such kind of a crystal structure or such kind of a cubic structure that defines the structure of a crystal is called as a unit cell. So how can I define it? It's a smallest three-dimensional group lattice point, which when repeated in three-dimensional space gives the whole lattice crystal. Am I clear? Now this unit cell can be seen in three-dimensional space, as we can see it over here also. Now these are the various arrangement that you can see of a single unit cell. It's the axes that it is defined in is called as an x-axis, y-axis and z-axis, and the angles made by them is called as solid angles, which is defined as alpha, beta and gamma. Now let us continue with what kind of different structures a unit cell can form. We have got a cubic system, tetragonal system, orthorhombic, rhombohedral, monoclinic, hexagonal and triclinical. Now all the features I've mentioned over here, like if I talk about cubic system, you can see all the sides A, B and C are similar. Even the angles are same and have 90 degree. Similarly, in case of tetragonal, A and B, length and breadth is similar, but the height is different. Orthorhombic also you can see the same thing. None of the sides are similar, but all the angles are 90 degree. Similarly, all the features can be read in this case. Now these are called as a primitive cell. Alright, primitive crystalline cells. Now you can already see over here the cubic crystals and the examples given over here. For cubic, it's sodium chloride, potassium chloride, diamond, copper, calcium oxide, etc. Similarly, tetragonal you can see over here, white tin, tin oxide, then titanium oxide, titanium dioxide to be more precise, then ammonium bromide, etc. So such kind of other things are also there, and you can see all the crystal systems written over here. But in this chapter, we shall be taking into consideration only the primitive cubic system. Alright, so we will be only doing with the cubic crystal. Now, to continue with the simple cubic system, let us understand the various types of simple cubic systems. The first one is called as a simple cubic system or unit cell. Second one is body-centered unit cell, face-centered and end-centered. Let us understand each one of it. In case of a simple cubic center, 1/8 of the atom surrounds the ends of each corner. Can you see? So total there are 8 corners, right? And each side would be covered by 1/8 of an atom. If you take a sphere and divide it into 8 equal halves, 1/8 of the part will make up this single corner. So therefore, how many atoms can be formed out of it? If you can understand like this, 1/8 of 8 corners will make up how many atoms? Only one atom. Similarly, in case of body center, a big atom would be there at the center and 1/8 of an atom would be present at the corners. Alright, so how many atoms would be there? First of all, 1 at the center, so therefore 1 plus 1/8 of the atom. And how many corners are there? 8. So therefore 1/8 is how much? This is 1 plus 1 is equals to 2. Next one is face centered. Now there are 6 faces altogether and each face will have a half of an atom. Alright, they'll have half of an atom, and of course at the corners there will be atoms, 1/8 of an atom. So therefore the number of atoms turns out to be 3 plus 1 is equals to 4. Coming to the next one, we have got n centered. N centers means only 2 n's will be included over there. Alright, so therefore half over here, half over here. So that will make a 1 atom, and 1/8 of the 8 corners, 1 atom. So total number of atoms present in the n centered is 2. Now children, let us continue with the question. Now if supposedly a question is given for you to find out the chemical formula of the compound with a description of the solid state given, how will you proceed to the problem? Now let us read the question first. A solid has a structure in which A atom are located at the corners of the cubic lattice. B atom are present at the center of the edges and C atom are at the center of the cube. What is the formula of the compound? Here we shall discuss about the solution. Now you can see over here, the question says A atom is at the corners. So total how many corners were there? Remember, there was 8 corners and each corner will have how much part of the atom? It will have an eighth, 1/8 of an atom. So therefore what will happen? 1/8 into 8 is equals to 1. Alright, so second part, this was A. How many atoms of A is there in a molecular structure? Only 1. Second one, B are at the center of the edges. So this is one edge, this is one edge, this is one edge, this is one edge. And you can understand this is one, it is at the center. Alright, this atom is at the center. Now you must be wondering that how much part of an atom would be there at the edge, center of an edge. If you can understand like this will be equivalent to 1/4 of the total atom. If you can take this atom 1/4, this 1/4, this 1/4 and this 1/4. So how much atom it will make? 1. 4 parts has been divided into, one part is divided into 4. Alright, so therefore this will be equals to 1/4 of the total atom. So B will be equals to how much? See, here it is just one 2-dimensional structure that is given, but we have to consider that to be, it is composed of 3-dimensional structure. So therefore there will be a total of 12 edges. 12 edges, this edges. Alright, so if there are 12 edges, so how many atoms are there? In each edge we have 1/4 of it. So 12 edges will have how much? 3 atoms. So how many atoms of B are there? 3. And C is at the center. Means at the center there will be 1, body centered. So therefore the ratio of A is to B is to C is how much? 1 is to 3 is to 1. Making the formula to be A, B3, C. I hope you have understood how to proceed with such kind of a sum. I'll give you an example, I'll give you a chance to solve another sum which will be discussed, the solution will be discussed in the class. Please go through the question, children. Read it very carefully and try solving it. I hope you'll be able to do the question and you'll find the solution. Thank you.